Hey there, mathematicians. I have a question for you. When you did your math the other day, did you double check your work? Did you go back? Did you do it again to make sure that you had the right answer? You did, right? Yeah. I bet you've heard your teacher say, did you double check your work? Go back and double check this. Well, that's what this video is all about, mathematicians. We are going to solve triple-digit subtraction problems using two different strategies. We're going to do this to make sure that we have the correct answer. It's really easy to make a mistake when working through math problems. It's perfectly normal to do that. It doesn't mean that you're not getting the idea behind it. It just means that you made a little mistake, and it's important to make sure that you catch it and go back and fix it. And that's what this video is all about. We'll be solving it two different ways. We're going to solve it using place value notation, and then we're also going to solve it in expanded form. Let's get started. All right, so first of all, let's build this in place value notation. Place value notation is just like using your place value blocks, but this is how you write it on paper. It goes by a couple other names that you might have heard, like sticker notation or quick draw. So we're going to draw 913 in place value notation. 100, 200, 300, 400, 500, 600, 700, 800, 900. I'll need 110, and I'm also going to need 3 ones. All right, we need to take away 9. Ooh, okay, so 9 ones we have to take away. The problem is we only have 3 ones. What are we going to do? Well, a 10 is just 10 ones put together, isn't it? Yeah, so can we break a 10 up into 10 ones? Sure we can. Let's do that. All right, so we're going to take care of that 9. So get rid of that 10, and we're going to turn them into 10 ones. So that was 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's take away 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, how many ones do we have now? 4. Okay, 4 ones. Perfect. Move on to our 10s. We have to take away 4 10s. Ooh, we don't have any 10s, mathematicians. We have none. Oh dear, we took that 10 that we had, and we broke it into 10 ones. Well, wait. We can use that same idea, right? Sure. Well, 10 tens is 100. So we can take 100 away and turn it into 10 tens. We got this. Okay, let's do that. So in order to take away 40, we're going to take away 100 and turn it into 10 tens, which is still 100. That was 30, 40, 50, 60, 70, 80, 90, 100. Now let's take away 40. 10, 20, 30, 40. So what do we have left? I say 6 tens. 6 tens is 60. So we're going to put a 6 in the tens place. All right. Last thing we need to do is take care of our 100. This should be pretty straightforward because we have enough hundreds here to take away. We have to take away 400. So let's do that. 1, 2, 3, 4. And how many hundreds are we left with? 4. So that's 400. Okay, So we have a 4 in the hundreds place, a 6 in the tens, and a 4 in the ones. So 464. All right, cool. Let's try it again a different way and see if we get the same answer. All right, we're going to expand it this time. All right, so this is 913 in expanded form. We're taking away 449. And we're running into that same problem we did on the other one. So we're going to have to take that 10 and we're going to have to combine it with our 1. So by doing that, we now have 0 tens, and that becomes 13 ones. We can solve 13 take away 9. That's 4. But now we have an issue. We have 0 tens minus 40. Can't do that. So just like in that last method we tried, we are going to have to take 100 and move it over into a 10. So remember, 10 tens make 100. So if we move one of our hundreds out of there and move it to the tens, we can do this. Okay. So 900 will now be 800, and that 0 now becomes 100. And 100 minus 40 is 60, and 800 minus 400 is 400. So then again, we have 400 plus 60 plus 4. Take that slinky, put it together, and we have our answer of 464, which, let's double check it. Let's see if we got the same answer last time. Okay, we got 464 last time, and we got 464 this time. So that means it checks out. We did it. All right, so mathematicians, when you do your work, I want you to choose one strategy to solve it, and then use another strategy to double check your work. Can you do it? I know you can do it. Good luck.